Good day, my students. You are welcome to another on mathematics. The lesson is organized by University Press PLC, the foremost publishers of various textbooks. One of the textbooks is this. You see it, More Mathematics. We have 6 series. One for GS1, another one for GS2, another one for GS3, SS1, SS2, and SS3. The lessons are organized, as I said earlier, to equip you for the examinations you are preparing for. Becker examination. You normally call it before junior WAEC. Not junior WAEC now, but Becker examination. The topic we are discussing today is very, very important because it covers at least 1/3 of your syllabus. We call it variations. Variations, from the word variation, they are what we call variable. Variations and variable. Let me give you an example. Your weight is a variable. Your height is a variable because your height depends on your age. As your age increases, your height must increase, no doubt about it, unless there is something happen or you are malnourished. Now, we have 4 types of variations. The first one is direct variation. The second one is inverse variation. The third one is joint variation, and the last one is partial, the one you call partial variation. We are going to examine them one by one. From the word direct, your weight is directly proportional to your age. That is for a growing child. My own age is not directly proportional to my height because I can't grow again. My height can never increase. It's now a constant. Now, when you are talking of a variable, something that changes anytime, 2 is not a variable because 2 is 2. Anywhere you go, 2 is a constant. Pi, the one you are used to 20/7, is also a constant. Now, when you are talking of variation, then we will talk of variables. I will take the first one, direct variation. That's the first one we are going to consider. Variables. I gave you an example of variable before. I said your height, your weight, your age. Another example of variables, those of you that are used to going to bookshop to buy books. If the price of a book is reduced, you may be encouraged to buy more. That means the price of that book and your demand is also a variable. So when we are talking of variables, we have 2 types. We have one variable depend on the other one. That is dependent variable. Dependent. The other one is independent. Independent variable. I'm not going to bother you on dependent or independent variables. Now, direct variables. Now there are terms normally used in mathematics. If I say A equals B and A B, please take note. This one means A equals B, while this one means A is proportional to B. For one variable to be proportional to the other one does not mean that that number is, that variable is equal to that one. Let me give you an example. For the fact that you have direct relationship with your friend does not mean that you and your friend are the same. Now this one means A equals B, while this one means A is proportional. This sign means proportionality sign, proportional, proportional. Why this one means equal to. Do not substitute this for this. I'm giving the introduction because we are still going to now look at this. Let's say a variable is on this side, let's say y, another variable is here, and you discover that you have this. It means as this one increases, this one also increases. There is a direct relationship between the two variables, and the way how to say it is this: either they write this or this varies directly, or they say y is proportional to x. Please, by the time I start working, you will discover, you may see this one in your exam, or the right one varies directly as x, or they say y is proportional to x. It means the same thing. It means the same thing. Now let's look at direct variation now. After introducing all the variations, I will now go to the textbook, because I want to assure you by at the end of the lesson you will be able to handle any of the variations, either direct, inverse, joint or partial. Look at this. A, if you see something, they may not write anything, they just write it like this. It means A is proportional to B. When A is 10, B is 4. Then he said the first question, find the relationship between A and B. Then the second one, find A when B is 25. Then the third question, find B when A is 18. They will just write it like this. By the time we are taking questions from your Becker, you will see that's how they, by the time you see it like this, it means A is proportional to B. Then they continue. Now the solution now. Please, I want you to be careful. Solution. Write the question. This is the question. A proportional to B. A is proportional means A is direct, because of there is no 1 over or something. It's directly proportional. That is why you have to take note of those 3 words. I mean 3 sentences. Solution A proportional to B. You rewrite it. You have to remove proportionality sign and change it to equality sign. Let me give you an example. Let me look at this. That's why we say notes. If I say 6 is proportional to 2, it is true. I am not saying 6 is equal to 2. If I want to remove this proportionality sign, it means I will say 6 is equal to a constant times 2. A constant multiplied by 2. Please, this one means times. Let me write it. Times 2. This k is unknown, is a constant, and you know that if a number is multiplied by 2 and the result is 6, that number is 3. That k is 3. 3 is a constant. The same thing here. To remove this, because we don't know the constant and you don't need to guess it, you say A equals a constant multiplied by B. Then you let them realize that K is a constant. K is a constant. K is a constant. Now they will give you 1 mark here. If you say A is proportional to KB, you are saying another thing. That is, from there, the rest, it means you miss the road completely. A proportional to B means A equals KB. Then we give you 1 mark for saying KB. You can use C, you can use D, you can use any of the letters, but don't use O. Do not use O, so that they won't misconstrue it for 0. From there, K is a constant. We are given some information. The first thing, when A is 10, B is 4. When A is 10, B is 4. Let me write A is K. In fact, you don't need, you can say KB. KB is K times B. Substitute for A and B as given. When A is 10, K is unknown, B is what? B is 4. Or this is the same thing as 4K. 10 is 4K. You remember, this is just a linear equation. You are looking for K, divide through by 4. 10 over 4 equals 4K over 4. You are trying to eliminate 4. This cancel this here, 2 here 2, 2 here what? 5. You say, therefore, you don't continue from here. You say this one means K equals 5 over 2. which is the same thing as 2.5, or the same thing as 2.5. Please, for God's sake, this is the value of k, 5/2 or 2.5. Now, the value of k is now determined. You can now find the relationship between A and B. Since A is equal to KB and your k is 5/2, substitute for k. This is 5/2b. 5/2b. A equals 5b/2. You can leave it like this. Or, you know, 5/2 is 2.5. You can say 2.5b. Please do not write. You know, I say 5/2. Do not write. Do not write you know, I said 2.5 because some of you may say this is 2.5b. In exam, they won't give you. Don't write it like this, please. Now, that is the value of A and B. This one means, now if you look up, I said A equals 5b/2. This is what we call relationship between A and B. Relationship between, that is my between A and B, or equation connecting A and B. If they ask you write down the equation connecting A and B, this is correct equation correct equation connecting A and B. This one is not the correct equation because we don't know the value of k. Now, to solve other questions, you have to find A when B is 25. Please take note. You can use this one to find A in the first equation, the first question, that is Roman 1, because the value of k is not there and you can't guess it. You only use the relationship between the two variables when found correctly. Now let's solve the first and the second question. The second and the, the first one is to find the relationship or the equation. The second one is to find A and B. To find A and B here, but they are not the same. B is 25. When B is 25, use the relationship A equals 5b/2 when B is 25. Therefore, A will be equal to 5 multiplied by 25 everything over 2. You know, B is 25. 5/2. You don't write 2 here, you write it here. It's still the same thing. This one equals 125/2, which is the same thing as 62.5, or you leave it like this, or 62.5 they will give you. But take note that you substitute. You don't just write this one on a sheet of paper and you jump here. probably you have access to calculator. Now the second question, you have to find B when A is 18. You use the relationship again. A equals 5 B all over 2. Now B is to be found when A is 18. You have to substitute correctly. If you don't substitute correctly and you get the same answer, because it's possible for you to giraffe, you get 0. Please take note. It's very simple. When A is 18, substitute 18 equals 5B all over 2. Please take note. 18 is 18 over 1. Cross multiply. Cross multiply. You know, at Beckett level, you don't need to assume, jump. You jump a step. You just say from here it's obvious now. You just cross multiply on the sheet of paper, and then you write down the answer. Now look up. From there, cross multiply. Cross multiply. 18 multiplied by 2 equals 5B. You know 5B times 1 is 5B equals 5B. You are looking for B. You eliminate 5 from both sides. 18, which is 36, equals 5B. You say 36 over 5. If you remember our mom math for GSS 1, chapter 2, substitution, evaluation. 36 over 5 is the same thing as 5B over 5. You are trying to eliminate 5. 36 over 5. You know it's 7 1 over 5. 7 1 over 5 equals B. And 7 1 over 5 is 7.2. But if you leave it like this, or if you leave it like this, you know you are at a basic level. If you say 36 over 5, you leave it like that, they will take 1 mark, because you are asking your examiner or your teacher to complete it for you. This is improper fraction. This is improper fraction. Now let's leave it like that. I will still give you more examples from our textbook, but let's move directly. Inverse. Inverse. From the word inverse, you know we have multiplicative inverse and additive inverse. Inverse, not opposite now. From the word invert, the inverse of 2, inverse. Inverse of 2, you know 2 is 2 over 1. This 2 is 2 over 1. The inverse, when you invert it, will be 1 over 2. The inverse of 3 over 2 when you invert it. So from the word inverse, because the statement will be the same, they write it like, because the example I will give you will look exactly like that from our textbook later. Now look at this. P varies inversely as the square of x. Another example. P varies inversely as the square of x. Now there are so many things they want you to do there. The first thing is it varies inversely. They may say it's directly proportional to the square of x. Please, they can use, don't be scared. Let's look at that quickly. Solution. the first thing you have to interpret it. P is a variable. It varies. I told you. Inverse means 1 over. This one varies inversely as the square of x. That is 1 over x squared. If it varies inversely as x, is 1 over x. If it varies inversely as the square root, is 1 over square root. So from here, I told you, you can substitute directly and say, if you say P is proportional to K over x squared, my student, this is wrong. Because of this, I told you to remove this and put this. This one must change to equality. So this one is P equals K over what? X squared. This one is correct, but this one is wrong. If you do like this and you continue, you substitute, you will get the answer, but you get 0 over 4 because it's normally 4 marks. Fortunately, in your Becker exam, it's normally a whole question. We will work one later. A whole question, very simple. Out of 3 questions, you get 1 neat. Let's continue. P varies inversely as the square of x. This is the relationship. Not the equation connecting them fully because K is unknown. You write it down for them so that you let them know that you know mathematics. Say K is a constant. K is what? K is a constant. Don't say arbitrary. K is a constant. Now that is that. That's the interpretation of this. P varies inversely as the square of x. Let's look at another one. You know, we are not to find value of P. We are not to find value of x and so on. But look at this. W varies inversely as the square root of n when W is 3 n is 36. Then the question says find W when n is 1 over 4. You know, when a question is given, don't panic. Just understand what to write down. In this case, let's look at it quickly. Interpret, because that interpretation to equality at your level is 2 marks. You first say W varies inversely. That is 1 over square root of n. Honestly, they will give you 1 mark for writing this. Because they know careless students will say W is equal to 1 over the square root of n. Then for saying W, remove proportionality sign. It becomes K all over what? The square root of n. They give you another 1. Even at SSC level. But at Becker level, because we want to encourage you. This one will be 1. This one will be 1. Then you now know that when W is 3, n is 36. Substitute. When W is 3, you say W is 3. What is K? You don't know it. Don't say K must be. Nobody asks you to guess. K is K because we don't know it. Everything all over the square root of 36. My student, they give you another 1. That is why you see some of you scoring A. There's nothing like A1 in your own. It's A, B, or 1 something. It's very cheap. We want to encourage you to be mathematician, engineers, and so on. Then what is the next thing to do here? Please, for God's sake, try to know that 3 is the same thing as 3 over 1. K is unknown. You must find it. Because we want to test your knowledge of solving simple linear equation. Cross multiply. If I were you, I would say this is the same thing as 3 over 1. Say, comma, 3 over 1 equals K all over. What is the square root of 36? 6. At your level, if you don't use negative, because the square root of 36 is not 6 alone. It is plus 6 and minus 6. But for your level, we mark plus 6. If you are at the SSC level, if minus is not, I say 0. But for your own, they will give you 1. You see now, 1, 1. To get to this, to know that the square root of 36 is 6, they give you 1. Now you cross multiply 3 times 6. 18 is equal to K. Honestly, you get another 1. That is why you get that 10 mark. You get complete 10 mark for these simple questions. K is 18. Now, after knowing the value of K, you go back here, not this place. Substitute for K. Substitute for K. Substitute for K in, let me write so that you know what I'm saying. And W equals K over root N. Substitute for K. What is your K? 18. Here. If you substitute it, if you say W is proportional to K over N, that's the end. Even if you get it, that's the end. Now, let's solve that one. The only thing they want you to do there is simplify. You remember the other time we discussed evaluations, simplifications, solving. We are now solving. 18 is our value of K. W is our K. All over root N. I'm rewriting it. All over the square root of N. Now we have to find W when N is 2, 1 over 4. That is where we are going. W is unknown. K is known, 18. All over, this is where we are going. My student, you know, at times when you see that type of thing, 2, 1 over 4, is fraction. Probably you are not used to it. That is why, let me write it, the square root of 2, 1 over 4. 2, 1 over 4. Note, 2, 1 over 4 is the same thing as 9 over 4. You remember in proper fraction. You may be thinking, this man, he said we should not leave something in improper fraction. But you cannot find this one unless there's no way. And if you say it's 2.25 and you are using your calculator, you may run into trouble. Then, you know 9 is a perfect square. 4 is also a perfect square. When you are finding the square root of a perfect square, the sum disappears. So this is the same thing as 18 all over the square root of 9 all over 4. You can find the square root of 9. That is 3. You can find the square root of 4. So this is the same thing as 18 over 3 over 2. Honestly, for substituting here correctly, because we know some of you will not substitute correctly, they may put 1 over 4 here. For knowing that 9 over 4, the square root of it is 3 over 2, they give you 1. Now, 18 over 3 over, you know the other time I told you that this is, if you go to page 38, look at all the questions here. you can solve the questions, and I'm assuring you, if you solve all the questions pages 38, 39, if you are given 6 objective questions, if you don't get up to 5 there, anytime you meet me, don't greet me, because it is so structured that there are so many things we want to test. I was telling you the evaluation, simplifications, and solving. We combine them together for you here, but at simplest form. Now let's continue here. We still want to ask you to simplify. This is another question. The 18/3/2, let me rewrite it for you, because I don't want them to cheat you. This is the same thing as 18 divided by 3/2, if you don't know. Because some of you is carelessly, you say 2 here, 1, 2 here, 9. I will say 9/3 is 3. No, that's not the answer. 18 divided by 3/2 is the same thing as 18, you remember, times 2/3. 3 here 1, 3 here what? 6. So the answer is 12. To give you another 1 mark here for knowing that this one is the same thing as this one, your final answer. Please, I want to warn you, don't say answer is 2. If you write this, they give you 0. It is not W that is equal to 12, but A and S. There are difference between A and S and W. Are you with me? Now let's move to the next one. The next one is joint variation. Joint variation. Joint variation. You know the meaning, the word joint. It will directly come to your mind that the variables are more than 2, because joint. Let me give you an example. Volume of a cylinder. Let me give you an example. Volume of a cylinder, height and radius, they are joint. Yes, there are relationship between volume of a cylinder, radius of a cylinder, and the height. That is joint variation. There are relationship between your height, your weight, and your age. If your age increases and your height decreases, it means something is happening to you. Yes. So let me give you how we normally write simple one for you. At times they will write it like the example. Joint. Join from the word join. Let me write it simply. Joint variation. Joint. Let me give you an example. Y varies directly as X, and jointly varies, and jointly varies as the square of Z. Then when Y is 8, X is 2, and Z is 1. And the question says, find Y when X is 3, Z is 2. It's a whole, in fact, in exam they will give you as a whole question out of 3. Just pick it, get it, and be jumping. Now let's look at it quickly. The first thing is to write down the relationship. Y Please, I will write it in two form because you supposed to combine. Y varies directly as x. Now, y is directly proportional to x. Y varies directly as x. This is this. The same y varies inversely as the square of z, 1 over z squared. This is z, though, not 2. You look at the two, you combine it together. It's the same y. In fact, if I were you, I will write it here. Y varies inversely z squared. We combine these two together. It's the same y. You will now say y varies as x all over z squared. It's joint variation. Y is proportional to x. At the same time, the same y varies inversely as the square of z. You know, this is proportionality. If you remember, I told you to remove this, we need to introduce a constant k. Don't say because I've been using k, you are free to use c, you can use a, but don't use o, please. Because if you use o, it may mean 0. Now let's continue. From there, remove proportionality sign. Y equals a constant x all over z squared. Now substitute using the given values. We are given value of y, we are given value of x, and we are given value of z. Those three values must be used. You don't cook your own value. When y is 8, when this one is 8, k is what? Is unknown. Don't think k must be something. Multiply by, you can use that small x to say multiply. What is x? 2. What is z? 1. You put 1 all squared. I told you there's 1 mark here, 1 mark here, 1 mark here. You are, because you know the interpretation of the question, you introduce a constant, you are trying to find the constant. This is 2k, another 1 mark. You say therefore k is 4. Because you multiply a number by 2 and the result is 8, that k is 4. Finally, you use the relationship. Because you are finding relationship. This from here, not from there. Hence, let me use the word hence. Y equals k, which is 4, x all over z raised to power 2. They give you another one. The question says, find y when x is what? When x is 3 and z is 2. I told you this is the relationship between y, x, and z. That is the equation connecting the 3. You know there are 3. That is why we call them joints. From there, our value of y equals 4. I said when x is what? When x is 3. When x is 2. And you can put it like this, please. And z is 3. That is 3 raised to power 2. Solve it. 4 times 2 over what? Over 9. What is 4 times 2 over 9? That is 8 over. You will get 1, 1, 1 up to this stage. Please do not change this one to decimal. If you change this one to decimal, you get another thing entirely. 8 over 9 will be 0 point something something. No. 8/9 is 8/9. You know, the other time I was saying, you know, our y is 8/9. If you say y is equal to 8/9 and you draw this, or you say answer is equal to 8/9, this one is wrong and this one is also wrong, because this one, nobody is asking you to do that. You are introducing another mathematical term. In this case, you are telling us a n s equals 8/9. And another, there are two errors here. Probably you don't know. For say ns, that is one error. Another error is to write 8/9 like this. This is still wrong. This is wrong. It's supposed to be 8 all over 9. Please, this one is computer term. We don't accept it again. You know, you are fond of saying a/b and you write it like, 2/3, you say 2/3. Nobody will look at it. Now, thank you very much. Next lesson, we are going to consider partial variation, and I will show you questions from past Becker exam from our textbook. Not only the SS3. Now, as I was saying the other time, honestly, you will find your senior secondary school very interesting if you follow us on this series of lessons, because we are preparing you so that you have smooth transition. Thank you. God bless.